Hi friends, welcome back. Today we are going to solve Codeforces problem Metro. Before we start looking into the problem details, examples and the solution, I want to mention that my channel is dedicated to help people who are preparing for any type of Java interviews as well as coding interviews. You will find a lot of helpful videos on my channel that will help you in your Java interview preparation and in your coding interview preparation. There are over 200 solved different coding varieties of questions which were previously asked coding interview problems by Google, Amazon, Facebook, Yahoo, Microsoft, Apple and many other big tech companies. So if you are preparing for any Java interviews or coding interviews, this channel can definitely be helpful for you in your job interview preparation. So please subscribe to the channel. So let's look into the problem statement first. Alice has a birthday today, so she invited home her best friend Bob. Now Bob needs to find a way to commute to the Alice's home. In the city in which Alice and Bob live, the first metro line is being built. This metro line contains n stations numbered from 1 to n. Bob lives near the station number 1, while Alice lives near the station number S. So S is variable, right? They will give us what the S is. The metro line has two tracks. Trains on the first track will go from 1 to n, and on the second track it will be in a reverse direction, right? So just after the train arrives to the end of its track, it goes to the depot immediately, so it is impossible to travel on it after that. Some stations are not yet open at all, and some are open partially. For each station and for each track, it is known whether the station is closed for that track or not. If a station is closed for some track, all trains going in this track's direction pass the station without stopping on it. When Bob got the information on open and closed stations, he found that traveling by metro may be unexpectedly complicated. Help Bob determine whether he can travel to the Alice's home by metro or he should search for some other transportation. So let's look at the input. So the first line on the input is N and S. N is number of stations and S is where Alice's home is, right? So for example, in this first example, 5 are number of stations are 5 and Alice's live at station 3, right? And the next lines described the first track, right? So if it is 1, then it is open. If it is 0, it is closed. So otherwise station is closed, right? So 1 means the station is open. So for example, this is the first track, so it is like station 1 is open, station 2 is open, 3 is open, 4 is open, 5 is open, right? And this is again a second track in reverse direction, right? So you can board this train from here and it is going from right to left, and this is going from left to right, right? So there are two tracks. So essentially what Bob can do is Bob lives at station 1 here, right? So he lives here, so he can go, the station is open, so he can board this train. He can go from here to here and here to here, right? At the three stations, Eliza's live, so he can get down here. So that's why he can reach to Eliza's home with the metro. So answer is yes. So this is what the problem is. So we have to print yes if Bob will be able to commute to Eliza's home by metro, right? That is the output, otherwise no. So let's take this second example over here on the whiteboard, so I can explain you in more detail. So this is number of stations are 5, which is given to us, and Eliza's live at station number 4, right? So Bob is located here now, right? Bob is located here at station number 1. So what he can do is he can board the train at station 1 here and he can go in this direction, right? And he can get, now these stations are closed, 2 3 4 are closed. Now 4 is where Eliza's live, right? So 4 is closed, so he can get down at station 5. 5 is open, so he get down at this station 5 here and he go from this line to this line, right? Again he can board a train here at number 5 station, right? And he will start going in this opposite direction, right? This is this direction and this is opposite direction, so he will get down here at station number 4 where Eliza's lives, right? So we have to output yes here, right? Because he can take a train, like this is, let's say, line A, right? So he can take metro line A here. He can get down at station 5. Now from station 5 he can take line B and he can go from 5 to 4. So this line A goes in this direction and line B goes in this direction, right? So this is what the problem is. So we have to find out if it is possible or not, right? So let me just remove this coloring so I can reuse this. So now what we can do is, if let's say where Alice lives, let's say Alice lives on station 4, right? If the station, first thing is this station has to be open where Bob live, right? If this station is closed, then right now, right there we will just output no, right? Because he cannot get into the station itself. So there is no way he can reach to Alice's home. For example, if his station 1 is closed, let's say, right, this station number 1, if it is closed, then we will output no. Now in this case station number 1 is open, right? 1 means it's open, so he will board the train. Now if this station where Alice lives, if this one is also 1, means if this station is open, then when the metro stops there, he will get down and he will reach to Alice's home. So we will output yes. If that is not the case, then another case is this last station 5, right? This station should be open, right? If this station is open and on both the lines, right, on both the lines the station should be open. As you can see here, both the line station is open, then he can get down on this station and he can go to this station, right, in the opposite line, and from there he will start traveling in opposite direction where the Alice's home is located. Now on this line B, if this station is open, which means that if it is 1, then we will output yes, because he can get down and he can reach to Alice's home. If it is 0, then we will output no, because the station is closed, so he cannot reach to Alice's home basically, right? So this is the logic to solve this problem on Codeforces called as Metro. So let's look into the Java code. So Java code is just the same implementation I just shown you here. So X is the number of stations, S is where Alice lives, and these are the A is the A stations array, right? 10001, and this is a B stations array. This is a line, this is B line basically, right? So we have one flag, which is 0 in the beginning. So first thing we will check if the first station where Bob lives, if it is 0, means if it is closed, then we will just make flag is equal to 1, right? And this, if flag is equal to 1, you can see here, if flag is equal to 1, it will be no basically, right? So for yes, it has to be 0. So flag is equal to 1 means he cannot reach to Alice's home if the station where he lives is closed basically, right? Otherwise, the station if where he lives is open, then he will start traveling in this A direction basically, right? In this A direction, he will take the train here and he will start going into this direction basically. So that's what we are doing here. So we are here, right? So A of stations array S minus 1, if it is equal to 0. What we are doing here is we are checking if on the A line where Alice lives, if it is 0, right, means if that station is closed, then our flag will be 0 basically, right? If that station is closed, then we will have to go and change the line, right, from A to B, because now using A line he cannot reach here because this station is 0, means it is closed. So it means that to reach to Alice's home, he has to transfer the line from this A line to B line, right, at the end station. Here he can transfer it at the end station, right, because train is going in this direction. So what we will do here is we will try to go into the end station, and we will, like, I is equal to S and I is less than equal to X, right? Means S is, for example, here in this case 3, and 3 means because it is 0 based index, right? And then we will try to go, it will go until 5, right, which is end. X is equal to 5 means I is less than 5, so it will try to go until end, and he will, once the A stations is equal to 1 and B stations is equal to 1 for the I, right, then we will just say temp is equal to 1 basically, right? So what it means is, after the station, basically what it means is after this, so what we are doing, let me just revert this coloring back so I can reuse this space again. So we are actually at this point basically, right, at the fourth point. Now we are checking if there is, because this station is closed, we are checking if any, we are checking if any of the forward station, right, further station is open basically, if it is one basically, right, on both lines, right. So if it is one, then he will get down on this station and he will go to this station on the same line, right. So that's what we are doing here. So, and we will set temp is equal to 1 if we find any station like that, right. And if temp is equal to 1, in that case we will go here and we will just want to check on the B line if Elisa's station is open, right. If Elisa's station is closed, then we will just make the flag as 1. Flag 1 means he cannot go to Elisa's home basically, as you can see. Flag 1 means no. So we will check, means he changed the lines, now he is on the B track, and we will check if on the B track Eliza station is open or not here, right. Now what happens if temp is equal to 0? If we cannot get into reverse track basically, right, temp 0 means that we just don't have any station on this track which is open, so we cannot change a track from A to B basically, right. In that case directly we have no basically, right, means because he cannot go to the Eliza's home because he cannot change the track, so flag will be 1. So in that case we will just print no. So let's just go ahead, this is the same logic that I explained you here with this example. So let's just execute this code with the example we discussed. So now it is yes. For the example we discussed, for this is the example, we are getting correct answer, yes. So now let's go and let's take one another negative example, 5 2. So I'll just modify this input quickly, 5 2, and then 0 1 1 1 1. So this is 0 and then all ones, right, 1 1 1, right, and this is all ones, right, all ones. So all ones are here. So let's just execute this code and make sure it works. So we are getting no, and no is the correct answer. As you can see, no is the correct answer, right. And why? Because the station, this 0 means where Bob lives, the station is closed, right, so he cannot get into the metro, so that's why it is no basically, right. So this is the way we can solve the Codeforces problem metro. This is the logic that I explain you with this example on this whiteboard. Um, so if you are new to my channel, there is a Codeforces playlist on my channel which has a lot of solved Codeforces problem explained with examples and Java code. You can take a look into that playlist to learn how to how to build up logic and solve different varieties of problems. There is another big playlist called as Leetcode and Leetcode solutions. It has a lot of Leetcode and Leetcode problems, which are coding interview questions asked by Amazon, Google, Facebook, Microsoft, Apple, Yahoo, and many other big tech companies. You can look into that Leetcode and Leetcode solution problems. It has really lots of good varieties of problems, which if you practice, it will definitely help you in your coding interview preparation. If you are simply preparing for Java screening interviews or telephonic interviews, there is another playlist called as Java interview on my channel that discusses a lot of frequently asked telephonic Java interview questions, and how to answer those questions is also discussed there. Apart from that, Java architecture and design patterns related videos are also available on my channel. You can take a look. If you like this video, if you find this video helpful and you like the way it's prepared with whiteboarding and examples and Java code explained, so please give it a like. Also share this video with your friends and colleagues. Subscribe to the channel, and it's very important your subscription for the channel, because that is the way the videos can reach to more people who need help in solving different coding problems in Java. They can look into these videos and understand how to approach different varieties of coding problems and what APIs and Java libraries to use, like classes to use to apply towards different coding example problems and solve those problems, because a lot of different APIs are very important in, for example, java.util has a lot of different APIs like array list, hash map, tree set, hash set, all those things, right. So they will learn how to apply different APIs on these problems. If you like this problem, give it a like. Also, if you have any questions, please write your questions below the description, and thanks for watching this video.